Hey guys, so we're going to be talking about the conditional statement now. So suppose P and Q are statement variables. Then the conditional of Q by P is if P, then Q, or P implies Q. And this is denoted by P and then the arrow symbol connecting to Q. The conditional of Q by P is false when P is true and Q is false. Otherwise, it is always true. P is the hypothesis or the antecedent of the conditional, and Q is the conclusion. When it comes to order of operations, in expressions that have the conditional operator with other operators like the negation sign, the and sign, the or sign, the conditional operator is performed last. So let's make some truth tables that deal with the conditional operator. So like how we did in previous videos, you first start the truth table by writing down all of the symbols. So there's P and Q, and then there's the negation of P, which is next. That's the next most basic component. And then the negation of Q. And then the next most basic component is connecting the negation of P or Q. So let's write that down, negation of P or Q. And then the very last column will be connecting the negation of P or Q, and then the conditional operator, and then the negation of Q, which we also have right here. So as you can see, as we write all the columns from left to right, the first row gets closer and closer to the entire statement form, which is what we want. So since there's only two variables, we would write for the first column true, true, false, false, and then alternate between true and false in order to get all the possible truth value combinations between two variables only. And then the negation of P is false, false, true, true. And then the negation of Q is false, true, false, true. And then negation of P or Q, let's see what that looks like. So false or true is true, false or false is false, true or true is true, true or false is true. And then here's where it gets a little tricky. So we are dealing with the conditional operator. Now remember, true implies false is always false. Anything else, so true implies true, false implies true, or false implies false, that is always true. So the only time the conditional statement is false is when the hypothesis is true and the conclusion is false. Otherwise, the conditional statement is always true. So here, we're comparing the negation of P or Q implies Q. So true implies false is false. False implies true is true. False implies true. True implies false is false. True implies true is true. This is the truth table for this statement form. Okay, let's do another one. Number 8. Number 8 says the negation of P or Q implies R. So let's see. We have 3 variables, so we have to put those down first for our first 3 columns. And then the next most basic component is the negation of P. So let's write that down. And then after that, we're going to look at the next most basic component, and that is the negation of P or Q. When you see the conditional operator, think of what's ever on the left of the conditional operator as one thing, and then what's on the right of the conditional operator is another thing. So that's why we want to treat we want to take care of what's on the left first and what's on the right first before we connect them together at the very end. So we have the left, we have the right. So now we just need to connect those two with the conditional operator. So the last column would say the negation of P or Q implies R. And since there are three variables, one neat way to get all the possible true value combinations is just to write true 4 times, false 4 times, and then alternate between true and false by 2's. So true, true, false, false, true, true, false, false. And then R, true, false, true, false, true, false, true, false. And then the negation of P is false, 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 true, 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 true. And then false or true is true, false or true is true, false or false is false, false or false is false, true or true is true, true or true is true, true or false is true, true or false is true. And then remember that true implies false is false, and then any other combination, so true implies true, false implies true, false implies false is true. So true implies true is true, true implies false is false, false implies true is true, false implies false is true, true implies true is true, true implies false is false, true implies true is true, true implies false is false. There we have it. This is the truth table for this statement form. All right, let's do the next question. Number 12 says, use the logical equivalence established in example 2.2.3, and they give it to us. So the logical equivalence is P or Q implies R is logically equivalent to P implies R and Q implies R. Use this logical equivalence to rewrite the following statement. Assume that X represents a fixed real number. So we're given that if X is greater than 2 or X is less than -2, then X squared is greater than 4. So we can see that if we break this sentence down into different pieces, it's going to have the same form as the left-hand side of the logical equivalence. So X is greater than 2 could be P. That's our P. And then the OR is matching this. And then X is less than -2 is Q. Okay, so let me color code this. So this is this part. So what's on the left of the conditional operator is P or Q. So what's on the left side is the if part of the if-then statement. So if P or Q is what we have, so P is equal to X is greater than 2, and Q is equal to X is less than -2. And now let's look at the right-hand side. So R is the then part of the conditional statement. So then X squared is greater than 4. So we know that R is equal to X squared is greater than 4. Now we want to rewrite this left-hand part of the logical equivalence into this new statement So we can just replace the statement variables with P, R, and Q. So here it says P implies R, so we can say if X is greater than 2, then X squared is greater than 4. And then the and symbols we just write and. Q implies R, so Q is X is less than negative 2, so we write if X is less than negative 2, then X squared is greater than 4. And so these two statements are logically equivalent. And we just rewrote this following statement into a statement that's logically equivalent to it, which is this. Number 13 says, use truth tables to verify the following logical equivalencies. Include a few words of explanation with your answers. So we're just going to do A. So we're going to write truth table for 13A. It says P implies Q is logically equivalent to not P or Q. So we will start writing the truth table by putting down all the variables in the first couple columns. So we have P and Q, so P, Q. And then the next most basic component is the negation of P. Negation of P. And then we have all of our parts. We have P, we have Q, we have the negation of P, we have Q. All we need now is the conditional statement P implies Q and the negation of P or Q. And whatever truth values come up for these two columns, we will compare them. If they have the same truth values, then these two statement forms are logically equivalent. If they don't have the same truth values, then these two statement forms are not logically equivalent. So since there are only two variables, we can do our handy trick of getting all the possible truth values between two variables, which is true, true, false, false, and then we alternate between true and falses. So true, false, true, false. The negation of P is false, false, true, true. And then P implies Q says true implies true is true, true implies false is false, false implies true is true, and false implies false is true. And here's a handy trick that I used when I was first learning conditional statements and the conditional operator. One way to remember that true implies false is TF is kind of saying the F word, and you don't want to say the F word, so you will say false, false. I don't want to say TF, right? You don't want to say that. So TF is a no-no, so that's always going to be false. I guess it's a little weird because, well, FT and FF also would include the F word then, but the phrase, the F word, like the fudge, like you don't want to say that. That's a common phrase and people don't want you to say that. So just remember TF is saying, or as being no, like false. All of the instances, TT, FT, FF, that's always going to be true. So when you see TF, just think the fudge, and that's a false. So, okay, and then now let's compare the negation of P or Q. So false or true is true, false or false is false, true or true is true, true or false is true. So these two columns have the same truth values, So the statement forms P implies Q, and the negation of P or Q are logically equivalent. Yay! All right, let's do number 21. So 21 says, suppose that P and Q are statements, so that P implies Q is false. Find the truth values of each of the following. So if P implies Q is false, the only possible truth values of P would be true, and the only possible truth value of Q would be false. That's the only instance where this statement form is false. Remember, TF, the fudge, right? Like, that's the only time this statement form with the conditional operator is false. So we know that P equals true and Q equals false. So now let's take a look at B. P or Q. True or false is true. And then now let's look at Q implies P. So Q implies P is like saying false implies true. And that's true because the only instance where this conditional statement form is, the only instance where this statement form is false is if Q was true and P was false, TF. But in this case, it's FT. So Q implies P is true.